In this example, we want to determine whether function g is even, odd, or neither. So we remember that when we do that, we want to evaluate the function at negative x and see what happens. If this is an even function, then when we take negative x and we fill in, we should get exactly the same thing we started with, g of x. So we would get x to the fourth minus 2x squared. If this is going to be an odd function when we evaluate at negative x, we should get the negative value of g of x, okay, which means that all of our signs would change. We would get negative x to the fourth plus 2x squared. And if neither one of those things happen, then we know our function is neither even nor odd. So let's begin by evaluating function g at negative x. We know that means we're just going to replace our x value with negative x. Alright, and then I know negative x to the fourth power means I've actually got 4 factors of negative x. So we'll kind of scratch that out so you can see what it looks like over here. When you do that, you have negative times a negative, which is a positive, times a negative gives us a negative, times another negative gives us a positive. We know because we have an even number of negatives that this is going to come out to be positive. So we have positive x to the fourth. And then right here I need to simplify this negative x squared first. So again, I have an even exponent, so that's going to become positive x squared. So I have minus 2x squared. So taking a look at this, I've got g of negative x equals x to the fourth minus 2x squared. So it looks like it's exactly the same as what I started with, which tells me if it's exactly the same, then we have an even function. Alright, let's take another example, and this time we have function f, so let's evaluate at negative x. And we'll fill in negative x wherever we see our x value. So this time we have an odd exponent, which tells me that this is going to stay negative. So I have negative x to the third here. And then I've got negative 6 times negative x, and I know negative times a negative is a positive, so I have positive 6x. So function f evaluated at negative x gives me negative x to the third plus 6x. So looking at my original function, I've changed the signs on both of those terms, which tells me that I've distributed a negative, just like this says over here, negative f of x, which tells me that this function is odd. Taking a look at this last example, we'll do the same and fill in our negative x. And I have an even exponent this time, which tells me that that negative is going to take care of itself. And we have positive x squared. 2 times negative x is negative 2x plus 1. So this time function h evaluated at negative x. If I look back at my original, it doesn't look exactly the same because this term is different signs, one positive, one negative, on 2x. It's also not exactly the opposite because that's the only term that has an opposite sign. So that tells me that this is neither an even nor an odd function.